My name is Keshwani. It's K-E-S-H-W-A-N-I, Keshwani. We are here because we're going to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 284. Page 284, today's our lesson number 130. The very first problem on the page, let's take a look at it. It's a very straightforward, simple question. What they're asking here is x negative? Very simple. Sorry, rather, they tell us that x is negative. X is negative. That is given. The question is x less than negative 3? Like I said, question may be straightforward. It is always the answers that get prickly. Let's see what they tell us in statement 1. In the first statement, they tell us that x squared is greater than 9. Now, people in their haste might come to the conclusion that x squared is greater than 9. That implies that x is greater than 3, and that's it. You must slow down. Whenever you're dealing with square quantity, you must slow down, and you have to ask yourself, what is the other possibility? This is only half the answer. X could be greater than 3. For example, square root of 4 is 16, which is more than 9. But so is, and also, x could be less than negative 3. For example, if x were negative 4, negative 4 squared is positive 16, and which is greater than 9? We are told that x squared is greater than 9. Well, there you go, x squared. If x were negative 4, the square of negative 4 would be greater than 9. X could be negative 10. Negative 10 squared again is greater than 9 because it's going to be 100. So there are two possibilities. So how do we show it on the number line? How do we show the solution to this thing on the number line? Well, it's going to go something like this. Here is our 0, 1, 2, 3, and x could be anything more than that right here. Anything, not including this part. We do not include the endpoint because it doesn't say equal to. And then again, 1, 2, 3. There is a negative 3. So again, not including this guy, anything on this side. So the question was, is x negative? So now the question is, how can we tell if x is negative for sure, if x can be more than 3 or less than negative 3? Well, that's where this fact is going to come into play, because they tell us in the beginning that x is negative. So given the fact that they tell us that x is negative, it is given x is negative. And there are two possibilities. X could be more than 3 or x could be less than negative 3. So since x is negative, x cannot be more than 3. So the answer is x would have to be less than negative 3. Less than negative 3. X must be less than negative 3. So the question simply was, is x less than negative 3? The answer is yes. X must be less than negative 3. That's the only way we're going to find x squared to be less than, to be more than 9. X would have to be less than negative 3, and when you square something that is less than negative 3, like negative 4 or negative 3.5 or negative 5, when you square it, it becomes a positive quantity, something more than 9. So the first statement does the job. We are able to answer the question. The question was, is x less than negative 3? The answer is yes. X must be less than negative 3, given the fact that there are only two possibilities. It can be either more than positive 3 or less than negative 3, given along with the fact that we are told x is negative, therefore it must be it. The first statement does the job. A, D, B, C, E. Since the first statement by itself works, answer cannot be B, C, or E. It will have to be either A or D. Let's look at second statement. In the second statement, they tell us that x cubed is less than negative 9. Now this is the tricky part. You have to pay attention here. First of all, it is x cubed, not x squared. X cubed is less than negative 9. Instead of x cubed being less than negative 9, had they told us that x cubed is less than negative 27, now that would have implied that x must be less than negative 3, because negative 3 square, negative 3 cube is equal to negative 27. But they're not saying negative 27, they're saying negative 9. So that's the tricky part. They're not telling that x cubed is less than negative 27. They're telling us that x cubed is less than 9. Is that enough for us to know? Is that enough for us to know if x is definitely less than negative 3? The answer is no. For example, x could be, see, here's what's going on. X cube is equal to 8. X cube is equal to 8, which means which means the cube root of 9 is going to be something very close to 2. As a matter of fact, I'm not going to do it here, but as a matter of fact, you should try it out. 2.1 times 2.1 times 2.1, you will see is something more than 9. And therefore, the negative 2.1 cube is going to be less than 9. It could be anything. Negative 2.1 is not the cutoff, but it's very close to it. It could, for example, it could be negative 2.5. X could be negative 2.5. Negative 2.5 is same as 2.5. 2.5 is same as 2.5. Let's find out. To make our work simple, we're going to start out with 25. 25 times 25. 25 times 25 is 525. 525 is 125, so that's a 5. Carry 12. And 2 5s are 50. 50 plus 12 is 62. Which is something, of course, we should have known. We should know our square of 25. 225 square is 625. Let's go one more round. 625 times 12. Let's do it here so we have the room. 625 times 25 rather. Again, 25 times 5. 25 times 5 is 125. 5 carry 12. 25 times 2 is 50. 50 plus 12 is 62. 2 carry 6. 25 times 6 is 150. 150 and a 6, 156. 156. Now this is all 2.5, 2.5. So there are two decimal places, 1 and 2. So this becomes 6.5. And then we do a 6.5 times 2.5. So now we have 3 decimal places. 6.25 times 2.5. So we have 3 decimal places. So it's 1, 2, 3. Turns out to be 15.625 equals 2.5 cube. You don't have to do any of this thing obviously in the exam. I'm just trying to do this here to make you understand that it is possible for x to be negative 2.5. It is possible for x to be negative 2.1, or x could be negative 4 for that matter. So here what we find is that x could equal to negative 2.1, and that cube is going to be less than negative 9. X could equal to negative 2.5, and then cube of that is going to be less than negative 9. X could be equal to negative 4, and cube of that is going to be less than negative 9. So how can we tell if x is less than negative 3? We cannot. X could be less than negative 3, but we do not know for sure. Because simply telling us that x cube equals less than 9 does not tell us for a fact if x is less than negative 3. We would have been able to say that. We would have been in a position to say that for a fact that x must be less than negative 3 had they told us that x cubed is less than negative 27. But that's the tricky part. Here they give you cube, but here they give you the square of the quantity, not the cube. They're not telling us 27, they're telling us 9. And they're hoping that in carelessness you might misread it and jump to the conclusion that x is less than negative 3. X is not less than negative 3. X is less than, a little bit less than 2. Just a little bit less than negative 2. Because as we just found, cube root of negative 2 is negative 8. Not cube root rather. Cube of negative 2. Negative 2 times negative 2 times negative 2 is negative 8. Therefore, just a little bit less than negative 2, if you cube it, you're going to get 9. Around 2.1. Negative 2.1, as we just found here. Cube of negative 2.1 is going to be very close to negative 9. Something less than negative 9, and so on and so forth. So the answer is, so the point here is the second statement by itself is not enough. Since the second statement by itself is not enough, here before we had A, D, B, C, E, we had found that the first statement was enough. Since the first statement was enough, answer we knew could not have been B, C, or E. Now we find out that the second statement by itself is not enough. Therefore, the answer is A. Only the first statement by itself does the job. Let's do the next problem. In the next problem, they're giving us problem number 102. In problem 102, they're simply asking us how many cans can be packed. How many cans can be packed in a carton? Well, that's a pretty straightforward question. We already know what we need to know. We need to know the volume of the, we need to know something about the carton itself, how big the carton is, and we need to know a little bit about the cans, how big the cans are. We'll find out what happens, okay, at the end, just what happens. In the first statement, they tell us that the interior volume of the carton is 2304 cubic centimeter or cubic inch, whatever. But simply knowing the volume of the carton is not going to tell, it's not going to enable us to tell how many cans we can put in it. We know how big the carton is, we know the volume of the carton, but without knowing anything about the cans, we cannot decide how many cans are going to fit in it. So the first statement by itself is not enough. First statement by itself is not enough. A, D, B, C, E. Since the first statement by itself does not do the job, answer cannot be B, C, or E. It will have to be either A or a D. Let's look at second statement. And if you still, second statement says that each can is 6 inches high and 4 inches in diameter. 4 inches in diameter. Well, now we know a little bit about our can. The can looks something like this. It's 6 inches high and 4 inches in diameter. So we know the height of the thing is 6 inches, and we know the diameter of the guy is 4 inches. So we can find out its volume. Volume of a can is very easy to figure out. Volume of a can and volume of a cylinder is the same thing. How does one find the volume of a cylinder? It's very simple. Volume of the cylinder, volume simply means how much stuff you can put in it, how much space does it hold inside it, which is very, in the case of a cylinder, is very simple. It depends on two factors. One is how wide open it is on the top, how wide open the can is the area of the circle here, the area of the opening, which is pi r squared. How wide open it is on the top, and how deep it is. How deep it is the height. How deep it is the height. And there you go, that's your volume. So now that we know the height of the can and we know the diameter of the can, we can find the volume of the can. We can figure out how big the can is. But just by knowing the volume of the can, it's not going to enable us to tell how many cans we can put in the carton, because the second statement tells us nothing at all about the carton itself. So second statement by itself is not good enough. Second statement by itself does not do the job. Therefore, the answer cannot be. I erased this thing. I erased, I think, the wrong. Either I erased the wrong thing, or this is sitting from the last question, so I don't remember it. So the first statement does not do the job. A, D, B, C, E. Since the first statement by itself does not do the job, answer cannot be A or D. We just found out the second statement by itself also does not do anything. Therefore, answer cannot be B. Answer would have to be either C or E. Putting them together might do something, in which case the answer would be C. Or if it doesn't do anything, then the answer would be E. Let's put them together, shall we? Together, let's put them together, yeah. Together, 1 and 2. Now, people in their haste might say that, might think that the first statement tells us the volume of the what do they call it? Carton. Second statement gives us the volume of the can, and they say, well, they're in their haste might come to conclusion that that's enough, because you divide the volume of the carton by volume of the can, you will know how many cans will fit in it. So in this case, they would sit there and divide 2304 by the volume of the can, which was pi r squared. R was diameter is 4, so radius is 2, so 2 squared times the height, which is 6, and they would simply assume that it's just a matter of dividing. It's just a matter of dividing one quantity by the other. Alas, that is not the case. That is not the case. Why? Because even though we know the volume of the carton, even though we know the volume, even though we know the volume of the carton, we know nothing at all about its layout. In other words, we know nothing about its dimensions. We know nothing at all about the dimensions of the carton. For example, for all we know, the so-called carton, could very well be 1 by 1 by 2304. The so-called carton could very well be 1 inch by 1 inch. In other words, on the very top, if you look at it, it's a very long tube. It's a very long square tube. On the top, it's a square, 1 by 1 square, 1 inch by 1 inch square top on the top opening, and it's a very deep tube, 2,304 inches deep tube. Well, if that were the case, how many canes will be able to fit in it? None, because a cane has a diameter of 4. Cane is not going to be able to, you're not going to be able to put any cans in it because the opening is only 1 by 1. So if this was something insane like that, you won't be able to put in any cans. And even if the openings were, let's just say the openings were 4 by 4, in which case, each side is a square of 4 by 4, you can actually drop a can in it. But without knowing the actual layout, you don't know if you can make 2 layers, and so in other words, we cannot find out the dead space without knowing the layout of the can. Without the layout, without its dimensions, we cannot figure out the dead space. What is the dead space? Dead space is the space that is not used inside the carton. For example, if you had, I'm going to give you something very simple. If you put right here, if you put, right, for example, if this were the case, say for example, this is your dead space, the space that is not being used. This is the dead space here. If you were to finish this thing, this is the dead space right here. This is the dead space right here. All of this is the dead space. And without knowing the exact dimension of the cartons, we do not know what the dead space is. We need to know exact, precise dimensions of it so we can lay out our canes in such a way that the maximum number can fit in it. But we know nothing about the dimensions. In the example that I gave you, in this case, the dead space is 100%. In other words, it's entirely useless. Not one single can can fit in it. We can go even more bonkers. We can go even more crazy. We can say maybe our so-called carton is 1/10 by 1/10 by 2304 times 100. Why not? There is no restriction on it. So now it's a very small square, 1/10 of an inch by 1/10 of an inch, and very, very long tube. Nothing is going to fit in. It's not enough. Putting the two statements together may seem like will do the job, and it may lead somebody to think that the answer is C. In fact, here the answer is E. The answer is E. That's all. I will see you tomorrow, okay? Bye now.